Hi, welcome to Num Club. This is Year 1 Pure, Chapter 3, Lesson 2, and today we're solving simultaneous equations including curves. Now, if you haven't watched the previous video about solving simultaneous linear equations, you must go back and watch it and pay really close attention to solving by substitution. Alright, let's get cracking with this question though. So, we need to find the points, the coordinates of the points of intersection. Now, this is not overly difficult, this question. A similar thing to this happened in the previous lesson, where if you've got y equals and y equals, just glue these equations end to end. So you'll get 4x plus 11 is going to equal x squared plus 3x minus 1. This has got a lot of the parts of a quadratic in it, but remember I said in a previous lesson you must never do anything with quadratics until they equal 0. So let's get this to equal 0. We get 0 is going to equal x squared. Take away 4x from 3x is going to be negative x, and take away 11 from negative 1 is going to be negative 12. Okay, we get that. If you feel more comfortable with the 0 being on the right hand side of your quadratic, just rewrite it. I know I do. I tend to just rewrite it. So to find the coordinates of the points of intersection, it's going to be the solutions to this. Okay, now this will be x minus 4x plus 3 when factorised. Again, you need to go back to a previous lesson if you can't figure out how to factorise. And so your solutions are going to be found when x is 4 and when x is negative 3. And ordinarily that would sort of be it. But we're finding the coordinates, which means we do need to consider the y parts. Substitute these into the linear. Okay, y is going to equal 4 lots of 4 plus 11. Y is going to equal 27. And so when x equals 4, y equals 27, that goes for both of these equations. The check is by subbing into the curve. Okay, don't substitute it back into the linear. If you substitute it back into the linear, you'll only check that much working. Okay, you'll check back to the last time you substituted into the linear. If you substitute this into here, you'll get 16 plus 12 take away 1, which does equal 27. And so we feel really happy about that. And what you'll do once you've checked that sort of thing, because it's a bulky bit of algebra, you don't want to go back by checking every single step. You want to go back by a quick check like that, that's much more secure. And once you're done with it, I tend to ask my pupils to put a little smiley face underneath it to say that it's done. Y is going to equal 4 lots of negative 3 plus 11. Y is going to equal negative 1. And so when x equals negative 3, y equals negative 1. Again, double check by substituting into here. Okay, you're going to get 9 plus negative 9 take away 1, which is negative 1. It's fine. Okay, now that's quite a simple question, but this is more interesting. We have a curve and a line. The way I know this is a curve is because it's got a power in it. Okay, if we have just x's, just y's, and just numbers, we've got a linear. Anything else is going to cause a curve. That includes roots, that includes cubes, that includes powers that aren't a power of 1. Okay, we've got all sorts of different things that can cause a curve. Linear is a lot more rare. Now we should identify which one is the curve and which one is the linear. Okay, which one's the curve, which one's the line? This is the line. And step 1 will always be pick a subject for your line. Okay, pick a subject for the linear based on how the C looks. Okay, based on how the curve looks. You do not want to make x the subject. If you make x the subject of this, yes, it's easy because you get y minus 5, but you're going to have to substitute it in and square it. It's going to be more work. It's going to be more chance to make a mistake. It's going to be more time taken up. If you make y the subject, you're going to end up with x plus 5 equals y, and you'll substitute in here. It's going to be really easy. So in this case, I'm going to make y the subject. Okay? And you need to change the subject in the linear. Okay, so I'm going to do that. I've got x plus 5 equals y, or y equals x plus 5. I'm just going to move the y over to make things a little bit easier. sub it in with brackets. I can't emphasize how important that is, because if you don't substitute it in with brackets, what's going to happen is you're going to end up with x squared minus x plus y plus 3. You'd end up with totally the wrong answer. So substitute it in with brackets, so you're going to get x squared minus x plus 5 plus 3 equals 0. Okay, we'll have to expand, collect, and solve. So let's see what that comes out looking like. We get x squared minus x minus 5 plus 3. There's your expand. Here's your collect. Okay, to solve this, we're going to go with x minus 2x plus 1. Again, if you can't remember how to factorise, you need to look back. And the solves are going to be x equals 2, x equals negative 1. Just let the brackets equal 0. Okay, don't forget y. Don't forget your other variable. Okay, where do we substitute this in? Let's have a look. Well, we've got three options. We can substitute it into the curve, we can substitute it into the linear, or we can substitute it into this thing where we change the subject in the linear. And in the previous lesson, I said that it was much easier to substitute in to wherever you change the subject. And that's true here as well. So we get 2 plus 5 equals y, so y equals 7. And so the coordinates of the point of intersection are 2, 7. Okay, when x equals 2, y equals 7. Substitute it in, double check it, make sure that it does. Okay, and we'll get negative 1 plus 5 equals y, y equals 4. Okay, and we get negative 1, 4. Nice and easy, not too bad. All right, make sure you follow those steps. If you're a person that follows steps, then get used to following those, and eventually you won't need to look at them anymore. All right, let's move on. So here's an exam question. It says solve the simultaneous equations. Now we've got which one's the linear and which one's the curve. Have a little look at it. Okay, you might want to go back to looking at the step-by-step guide. I'm going to pause here though and give you a chance to try this one out. All right, you'll probably have noticed that there's not an easier variable to substitute in as. Y squared and x squared are both equally difficult, and so we'll keep the linear in the same form that it currently is, which is y equals x minus 2. Okay, so we're going to substitute that in. We'll have x minus 2 all squared plus x squared equals 10. It's going to be x squared minus 4x plus 4 plus x squared equals 10. That'll be 2x squared minus 4x minus 6 equals 0. Okay, so that's substituting in, expanding, collecting, and we're going to tidy it up. Now here, there's actually a really nice move that you can do. You can divide through by 2. If you do that, you'll get x squared minus 2x minus 3 is equal to 0. It's a lot easier now because this is simple factorising, whereas this is a bit more difficult. You can if you want. If you didn't spot it, you could have just done normal factorising and you would have got the same answer out. But we're going to get x minus 3, x plus 1. So we get x equals 3 as one of the solutions, and solution 2 is going to be x equals negative 1. All right, if y equals x, take away 2, y equals 3, take away 2, y equals 1, and so we get 3, 1, not too bad, and y is going to equal negative 1, take away 2, y is going to equal negative 3, and so we get negative 1, negative 3. Okay, there you go, 7 marks. Imagine getting 7 marks for that. It's really easy stuff. Substitute this into the curve. 3 squared plus 1 squared equals 10. Fine. Negative 1 squared, negative 3 squared plus negative 1 squared is equal to 10. That's fine. Okay, so we're absolutely happy that we've got that right. Okay, and what you do is you put a little smiley face and you'd say, I'm not coming back to that one. All right, a nice easy question to get 7 marks on. All right, this is a bit more difficult because it includes the discriminant. Okay, this is our last question of this lesson. This one includes the discriminant, so it's much more difficult, but it's interesting enough for us to be able to have a look at it. It's a little bit of a stretch really at this point. I'll pause and you can have a go at it, but if you can't figure this one out, don't feel bad. All right, let's crack on. Given that the simultaneous equations are 2x plus y equals 1, that's a linear. Okay, that's linear. And this will definitely be a curve because it's all over the place really, isn't it? Where k is a non-zero constant. A non-zero constant means that k can equal any number, okay, apart from 0. So k could be 1, k could be 2, k could be negative 1, it could be negative 2, k could be a half, k could be negative 0.4. Okay, it can be a decimal, it can be a fraction, it can be negative, it can be positive, but it cannot be 0. Okay, given that x squared plus 8kx plus k equals 0, we'll get to that in a sec, has equal roots. This is the discriminant part, isn't it? Show that x squared plus 8kx plus k equals 0. What we're going to do here is we've got simultaneous equations, and as soon as we start looking at simultaneous equations, change the subject. Looking here though, we want to keep x's. Okay, so I want to keep that as it is, so I'm going to need to make y the subject of this, because that way I'll get y equals 1 subtract 2x, which will substitute into here, and we'll create more x's, and we want more x's. So we'll get x squared minus 4k lots of 1 minus 2x. Remember to substitute in with brackets, plus 5k equals 0. We'll get x squared plus 8xk minus 4k plus 5k equals 0. And we'll get x squared plus 8. I've got xk, so it should be 8kx. That's probably much better as well. 8kx. X should go last. Plus k equals 0. Alright, done. That's 2 marks, done. Alright, when you're doing these questions and they say show that, even if you couldn't figure this out, you can still have a good go at B and C. So show that questions are a bit of a gimme. They're easy. They're much easier, because if you can't work out A, you might still be able to try out B and C. So don't give up. Alright, given that this thing has equal roots, now equal roots will mean that you've got 2 roots in the same position, or you've got one solution. Whichever way you think about it is going to be, but b squared minus 4ac is going to equal 0. Whenever a question starts talking about roots, start thinking discriminant. Okay, so b squared minus 4ac. We've got 8k is b, because that's the coefficient x, minus 4 lots of 1 lots of k is going to equal 0. That's 64k squared minus 4k equals 0. And we're going to find the value of k. So I'm going to divide through by 4 as well. Alright, we'll factorize it. So we'll get k lots of 16k minus 1 equals 0. And you get your 2 solutions, which are k equals 0 and k equals, let this equal 0, 16k minus 1 equals 0, 16k equals 1, k equals 1/16. So your graph of your discriminant will look like this. You get 0, you get 1/16. Okay, it'll go through like that. Alright, we want the bit where it equals 0. So where does it exactly do that? So the value of k is going to either be 0 or 1/16, but k is non-zero. Pay close attention to stuff like that. So as k does not equal 0, k equals 0 is not a valid solution. So k equals 1/16. For this value of k, find the solution to the simultaneous equations. Now finding the solutions to the simultaneous equations is going to involve us using 1/16 as the value up here, isn't it? Okay, so we've got 1/16. It's going to give us just one solution out of this. So we had, you could substitute, you could change this to 1/16 if you wanted to, and you'd still substitute all this stuff in, and you'd still get to this point here with 1/16. And so I'm going to just deal with x squared plus 8 lots of 1/16 x plus 1/16 equals 0. That will be x squared plus 1/2 x plus 1/16 equals 0. Alright, and we're going to need to try to find out what the solution to this thing is. Okay, a little bit awkward. I'm going to complete the square on it, but you might well use the quadratic formula. It's up to you, really, to be fair. For me, I'm going to use completing the square because it's only got one solution, so I'm expecting it to be pretty easy anyway. You could also, if you wanted to, yeah, the quadratic formula is probably just as simple. So we'll go with x plus 1/4 all squared minus 1/16 plus 1/16 is going to equal to 0. X plus 1/4 all squared is going to equal to 0. Square root of 0 is plus or minus 0, so x will equal negative 1/4. Okay, you can move the root, move the squared over to make the root, move the quarter over, and job's done. Okay, x equals negative 1/4. Now that's part of it, but we also need y. Don't forget that. That's really important. Y is going to equal 1 minus 2, lots of negative 1/4. Y is going to equal 1 plus 1/2. Y is going to equal 3 over 2. And so your solution will be negative 1/4, 3 over 2. Okay? Cool. That's it. Thanks very much for watching. Visit numberclub.org to find some more videos and tasks. If you get a chance, subscribe to the channel. Thanks very much. Cheers.